Hi everyone, I'm Nemo.
And I'm Angus, the founder of Asseti, a platform used by rural asset owners to predict, plan and operate their property assets. So in terms of the market we play in, it is truly enormous. Anything that's a non-residential building is effectively part of our addressable market. That's 1 trillion square feet. That is an enormous challenge that can only be addressed using AI. And so for some companies, AI is fun or novel to use, but for us, it's really key to scale and actually being able to capture the addressable market. What you see here on the screen with the green dots, this is out of our admin system a few days ago, so about 135,000 properties currently managed in Asseti with their condition across Australia and the US. In terms of generating insights on those, we have had challenges in the past with people in the loop, humans in the loop, and that's really what we wanted to address here with Google.
So as you can imagine, our enterprise customers have anything between hundreds to tens of thousands of assets that need to be captured and processed into our platform. Our current processing capability has an AI model, but generally it takes about 3 to 5 days to process those assets and put into our platform for the customer to get their insights and get the aha moment of our product, which is a significant bottleneck as we start to scale and grow into the US market.
So in terms of our existing state, we've got tens of millions of images, components, defects that exist in our system. But due to some previous decisions we made, these existed in a range of formats, lines, points, and areas. And that was something that we addressed as part of this challenge or as part of this process. So we generated a tagging tool internally that enabled us to transition point components to area components. And our team tagged a portion of that, and then we'll get into some more around that. But it's really about being able to bring on these new component types. Height safety is an example. As height safety regulations change, more and more new component types are coming in that we're starting to detect in the system, and they're becoming quite prevalent. And being able to bring these on at speed is really important. So what we're looking at here is sort of the output of the AI itself, and so. Effectively what we're seeing here is each individual component on the roof, so colour-bond sheeting, polycarbonate, etc. What we see down the right-hand side is an alignment process as well. So because we see this data over time, it's really essential for us to know that it's the same colour-bond sheet 10 times rather than 10 new colour-bond sheets, because this feeds directly into the asset hierarchy that we generate for the customer. And what we can see down the very bottom right is a completely snapped-in image, fully automated, that was from a new survey, completely aligned to the site, snaps the components on, without any human intervention.
So our original model had initially started with humans, with AI, then human QC, and as you can imagine, it takes a long time. So what used to take 3 to 5 days, with our new model, we're looking at about a couple of hours. We're getting about a 65% accuracy rate, and it's significantly unlocked our processing capabilities.
So we thought, how best to put it into action for this than do the Google data center network in the US. And so we detected 15 locations across the data centers that we found. We were able to find 214 assets or buildings on those sites. And then across those buildings, we componentized it into about 5,500 components on the building envelope. What we'll do is we'll sort of run through a demo of it here. So this is a data center in Texas, Midlothian Data Center. And so what we're seeing on the left-hand side is the asset hierarchy that's been built out automatically by the AI. So we receive the visual imagery, and we build this out. We give condition scores, forecasts, replacement costs, etc. And we're going back and forward here on the timeline. And then this will work through the system. We have high resolution sort of levels that come in. And then this will be used for the defect detection.
And the only critical issue that we found was Bezos trying to get into the GCP secret source.
So obviously, really important issues that we help customers detect.
So what does this mean for us? So as we move forward, we're looking at adding hundreds and thousands of new components into our platform and being able to unlock our scaling capabilities into the new market, especially the United States, which has property like there's no tomorrow.
So in terms of a thank you, the whole Google team, Christine, Georgie, Scott and Mike, everybody else, and Trent, obviously, my God, sorry. speaker notes did not turn up, Trent, or they actually did. So Trent's been amazing, our anchor tech mentor, across the process. I had a child born in the process, and Trent really actually stepped in to support the team too. So amazing. That was planned, by the way.
Thank you. It was incredible. Thank you, Nima and Angus. Obviously, data plays a critical part of your business. Can you share with us how you tag the data?
Yeah, so as I said, we had this challenge around point components and transitioning those into a tagging model. So we built a really light tagging interface, used that to effectively build a smaller sample set, which we then ran through a training process to pre-tag a larger training set, effectively, which was then human validated, and we then ran that through. And we continue to use that for bringing new components on a weekly basis. We trained a new one with a random skylight that we've started to find in a specific area in the United States. So it's super valuable and has been great as part of the process.
Thank you so much. This time is for